My name is SREEHARI and my topic is urban heat islands. Mitigation planning for urban heat islands, Cochin City. So coming to urban heat island is a phenomenon that occurs when the air temperature in urban areas is higher than that of surroundings. And there are mainly two types of urban heat islands. They are surface urban heat island and the atmospheric urban heat islands. The surface urban heat islands are predominant, mainly have more spatial and temporal variations and are mainly observed in daytime, whereas atmospheric surface heat islands are have less variations and are predominant during the night. And the surface upper heat islands are mainly depicted through thermal images, whereas atmospheric upper heat island is depicted by isothermal maps or temperature graphs. So the main determination measurement approaches are the thermal image sensing, small scale modeling, and field measurements. Thermal image sensing is used to identify the surface urban heat islands. So the major causes are the urban surfaces, dark urban surfaces, lack of vegetation, urban geometry, building materials, etc. And whereas the effects are lower air quality, lower wind quality, increased threat to human public health, and global warming, etc. And the mitigation strategies include green roofs by sprinkling, vertical greeneries, use of higher albedo materials, and increasing the vegetation, etc. So coming to the study area, introduction to the study area. The study area is Kochi city region, where the Kochi is the most densely populated city in Kerala, with having 11 lakh urban population within the area of 370 kilometers square, and also it is situated in Ernakulam, which is the most urbanized district in Kerala. Coming to the mean temperature of Kochi from 2009 to 2019, you can see the mean temperature has increased from 27.4 to 29.6 degrees Celsius. And the aim is to formulate mitigation plan for urban heat islands in Cochin city, and to find the major factors affecting the urban heat island, to analyze about the presence of urban heat island in Kochi, and to identify and analyze critical areas, to estimate the mitigation effectiveness of the mitigation strategies through modeling, and to propose mitigation plans and strategies. The scope is that the research finding can be used for proposals that can mitigate UHA. Limitations are mainly relies on remote sensing data, and the study concentrates on selected parameters, and the validation of modeling is also now done. And coming to the methodology, mainly the study part consists of literature study of the concept and factors. There are several case studies, policies and regulations, and mitigation from the concept. The mainly parameters will be identified, and from the case studies also strategies and policy adopters will be identified. And coming to the data collection part, the land use, landsat images, estimates, and field observations are the main data that are collected. And from that, thermal maps, ground cover maps, and DB maps are generated, and the build-ups are taken from the land use map. And then field observations are used for taking surface temperatures. And then data analysis part, then land use analysis, and the temporal, thermal, and ground cover analysis, and the and the map is overlaid overlaid with the thermal map, and then the critical areas are identified, and a modeling and analysis of mitigation measures are also the part of data analysis, and the thermal behavior also identified, and the adaptation mitigation strategies for Kochi will be developed. And these are some of the factors such as daytime. The surface about urban heat inland is predominant, and coming to the wind and cloud cover, which is directly proportional to the urban heat island. And coming to the climate, topography, and surroundings, such as the presence of a lake can drastically decrease the urban heat island effect in daytime. And coming to ground cover, such as increased green cover decreases the urban heat island effect. And coming to materials used, the materials used higher albedo materials reduces the overheat effect. And then another factor is the heat produced by the human activities and the urban morphology, which includes the dimensions and spacing between the buildings within a city. And the urban heat element mitigation projects implemented in other countries include urban afforestation programs, such as tree planting strategies, urban agriculture programs, and then coming to green reflecting measures such as cool roofs, green roofs, which are implemented in Basel, and development of a sustainable infrastructure such as efficient, energy efficient buildings, and then reduction in the anthropogenic heat generations, such as promoting pedestrian, cyclists, promoting EV vehicles, etc. These are some of the studies which have been done in India with respect to urban heat island, and the main methodology includes studying the behavior using the thermal maps through Landsat images and then through field observations. And the main factor they have identified is the increase of urbanization as the mainly identified the urbanization as the main factor for the increase in the temperature, increase in the urban heat island effect. And these are some of the regulations currently in India for the climate change. We are having Kyoto Protocol and APCC, and in health and comfort we are having guidelines for preparation of action plan, which is for prevention and management of heat wave. Then in sustainable infrastructure we are having energy ECBC code for which is for the commercial buildings, and then we are having GRIHA, National Building Code, and then we are having the URPA guidelines. And these are some of the city level case studies. In most of these case studies, the main methodology is thermal mapping, ground cover mapping, and Landsat images, ground cover mapping to Landsat images. And the mainly identified cause for the urban heat and effect include dense built up areas, loss of lack of surface, lack of green or tree cover, and use of low surface albedo materials. These are some of the main causes that are identified. Then the main mitigation strategies they have suggested includes cool roofs, cool payments, and use of increasing the increasing the area of greenery. These are some of the mitigation strategies which have been identified. And then come to a case study in Singapore, which is similar to Kochi city region. And in the methodology, they have used remote sensing data from USGS, and then they have classified the local climate zone, and then generation of LS2 estimate. Then they have analyzed the area, and at the daytime they observed that low wind, low rise have the maximum temperature, whereas at the night time water bodies registered the maximum temperature. And then some mitigation strategies were suggested, which include in vegetation such as green roof vertical groups, and promotion of parks and open spaces. In urban geometry, which includes breezeways, uh, uh, breezeways, and open spaces to road junctions, etc. And in the materials used, they have suggested cool payments, permeable payments. In building level, there are cool roofs, cool facades, etc. And in shading, which includes the urban geometry such as building orientation, shading on buildings, and shelter design such as permanent shading devices, etc. And transport, they have suggested traffic reduction measures such as centralized routing system, active mobility system, etc., and reduced fuel consumption, and reduced fuel consumption. And then Mexicali they have used digital satellite images from Landsat, and then they have done a modeling. These are the LST map generated, and they have from LST map and the land cover they have analyzed the urban heat and effect. Then the findings were such as cool roofs and cool pavements and green spaces were suggested as the main implementation strategy, and a dynamic modeling was done. And from the modeling, they have observed a 6 degrees Celsius reduction by 2030 if it's implemented. And then coming to Bangalore, then the methodology is like there are two phases. First phase is for field measurement using field measurement for quantifying urban heat level, where IR thermometers were used, and the second phase was to observe the thermal performance of various mitigation options, where environment was used, and several sites were taken, and the finding was that low mean temperatures were obtained at IICS, where the green cover was more, and then the heat flux on the heat reflective RCC roof is almost 67 percentage less as compared to the uncoated RCC. And from the modeling also they have identified that 1.5 degrees Celsius temperature difference decrease was observed for reflective roofs, and 1.9 degrees Celsius in case of green roofs. Then this is a study area which is Kochi city region. The main highways includes NH70, NH47, and NH49, and the nearest airport is Kochi International Airport. And the Kochi city region consists of 16 local bodies, whereas where the Kochi corporation is the highest, which is the largest, which comprises of 94.88 square kilometer. And coming to the population density, the highest population density was observed in Kochi city region, Kochi corporation itself, whereas which is 2 to 3 times than the surrounding local bodies. And then the Trikakara, and towards east is the decadal growth rate map shows higher growth rate towards the east, which is which is to the east, and which is the highest was recorded in Trikakara. And coming to the temperature data, the maximum mean temperature, maximum and minimum temperature was observed. Maximum and mean temperature was observed in March, April, and May season, and the mean total rainfall was maximum in June. And from the maximum temperatures in 2001, 2019, you can also see an increase. And coming to the air pollution data, the PM 2.5 concentrations were mainly concentrated in the central part and towards the Kochi, towards the airport. And this is a land use map of the Kochi city region. And the major land use is residential, with having 43% of the gross area, and followed by the main deficiency was in commercial area, which constituted only 0.9% of the gross area. And also the parks and open space only constituted about 0.3%, where 14 to 16% was recommended by URDPI. And coming to the classification of road and length of road, there is 613 kilometers square of kilometer of road, where 56.6% of road is single lane road. And coming to the classification of roofing materials, the main roofing material is concrete, which constitutes of 69% of the area, 69% of the total houses, and then followed by 20% of machine made tiles, and then 5% of roof by GA and asbestos sheet. And coming to the methodology, for the land cover classification, land surface map, which is depicted here. For the land cover, for the generation of maps, the parameters were taken such as months, March, April, and May, and cloud cover less than 2%, and the data having no SLC error. And these are the maps generated. These are the land cover map generated, and this is the built-up change map. And coming to the land cover map, we can see the vegetation has decreased from 49 to 37% from 2000 to 2019, whereas the major increase was in the built-up area, which has increased from 20 to 38%. When we see the built-up change map, we can see the temperature has the built-up has increased more towards the east side of the Kochi city region. And coming to the normal NDVI map, the NDVI map shows that the lowest dense vegetation was observed in Mattancherry regions and the central core part of the Kochi city region itself. And the higher dense vegetation was observed towards the east side. And these are the land use land surface temperature maps of 2019. The main thing is the main increase is that the mean surface temperature has increased from 29.96 degrees Celsius to 31.3 degrees Celsius by 2019. And we can see that the increase in built in 2000, the 47% of the KCR region had surface temperature between 28 and 30 degrees Celsius, which increased to 20% by 2019. Whereas the areas having surface temperature between 32 and 34 degrees Celsius has increased from 11.5 to 33.4 degrees, 33.48 percentage. And to find the relation between the LST and the land cover map, an east-west transition was selected across the KCR region, and the temperature along that area was studied. And we can see the higher temperatures were obtained in port in Wellington Island, where port activities were taking place, and higher temperature were also obtained in Matancheri, and lower temperatures were mainly obtained in the water bodies and where vegetation was present. And these are some of the hotspots and heat sinks that are analyzed. These are the LST map, Earth map, land cover map, and the land use and the NDPA maps. We can see that in Matancheri, the possible factors affecting the surface temperature was low green cover, low rise, compact, unplanned layout, and low NDBA values. Whereas in Kochi city region, it is the industrial activities. In Ernakulam railway station, it is the use of low surface materials. Then we are having some industrial areas also registered high temperatures, such as the HPCL, Apollo tires, etc. And whereas heat sinks identified include NGO quarters where it is predominantly residential and increased they have increased tree cover, and most of them have reflective material, reflective roofing. And higher temperatures were obtained in dimensions such as Edapalli, where anthropogenic heat generations are higher, and the vegetated areas also registered lower temperatures. And coming to the study of surface temperatures of existing surfaces, an area was taken in the Kochi city region for analyzing the difference in the temperature, and air thermometers was used for measuring the surface temperature at 1 hour differences, and average of 5 points value were taken for the analysis. And these are the temperatures, and you can see higher temperatures was obtained in asphalt road, whereas most least temperatures was obtained at green areas. And the temperature, another important fact is a 5.6 degrees Celsius difference in peak surface temperature was observed between asphalt and concrete, and the lowest peak time temperature was 42.3 degrees Celsius, which is in grass. And for finding the 50 minutes of the mitigation measures, such as green roofing, modeling was done, which was done for the existing layout, maximum FR conditions, and for different layers of maximum FR conditions, and for the roofing materials. And for this, InvMet was used for the analysis. This is a brief methodology, and a site was selected for the analysis of the existing area, which is predominantly residential, and having a surface temperature between 32 and 34 degrees Celsius. And ease of modeling was also an important factor for the site selection. And this is the area which was modeled. The parameters which were taken included the height of the buildings, the type of roofing materials, and the area was digitalized and digitalized. And then for the model for maximum FR condition, the maximum FR for the maximum FR condition, Kerala municipality building rules were followed, and three type of buildings were chosen, such as high rise, low rise, and medium rise. These are the details of buildings and the detailings of for the roads, and this is the layout. And coming to the analysis was done for two models: for the base model, which is the original state of building and built environment, and for the mitigation model, which is for the mitigation model, 50% of green concrete roofs was replaced by green roofs, and 50% to cool roofs. And then the soil was replaced with light colored pavement, and soil was covered by grass, and the tree cover was increased from 10 to 20%. These are the values, different values of surface albedo. And for the model parameterization, WRF model was used for the model parameterization, and a sunny day was chosen with maximum temperature in the month was identified and chosen for modeling. And the observation is that in the existing layout, the maximum temperature decreased from 33.4 degrees Celsius to 32.74 degrees Celsius, and in the maximum FA condition, the maximum temperature decreased from 33.38 degrees Celsius to 32.6 degrees Celsius, and also the maximum temperature in the existing condition, maximum surface temperature decreased from 38.12 degrees Celsius to 32.69 degrees Celsius. And another factor is the mean radiant temperature, which is the weighted mean of temperature of all objects surrounding the body, and the lower MRT were observed in east-west direction due to the shading of buildings, whereas lower MRT were also observed near the trees. And three maximum FR conditions was also analyzed, such as high rise, medium rise, and low rise development. And the observation is that the air temperature doesn't have much difference in three of them, but the mean radiant temperature was lower in the high rise layout, and the mean radiant temperature was maximum at the low rise layout. The temperature values were 35.53, 36.73, and 36.98 degrees Celsius. And then another mitigation, another modeling was done with identical buildings having different roofing materials, such as conventional roof, white roof, and green roof, respectively. And the observation is that in conventional roof, the temperature reached up to 35.80 degrees Celsius. Air temperature room temperature reached 35.80 degrees Celsius. White roof reached only 33.59, and whereas in green roofs it reached only 31.60 degrees Celsius. And also another important factor is that the mean radiant temperature above the white coat roof was 0.05 degrees Celsius higher than the RCC, which is mainly due to the radiation of heat back to the atmosphere. And coming to the analysis, the issues identified in coming to the north region, the issue was identified that it is predominantly industrial area with use of low albedo materials. In the Kochi city region to the east, which are newly developed areas with no consideration for UHI, and the high-rise development and rapid decreasing in the green curve. And in 3, which is a corporation of Cochin, where which is densely populated region with high vehicular traffic, and hotspot identified includes railway stations, industrial areas, etc. And then the Villante Island, where the port activities are present and have low albedo materials, and the Mattancheri area, where the DV value is low, and which have a mixed use area having under the heritage zone, which are the oldest settlement. And the issues identified in laws and regulations include there are no policies rarely addressing mitigation of overheating, and the ECBC does not are not reinforced in Kerala, and the green roofs are only included in the respective requirement of the code, and the existing buildings does not have any regulations for UHI, and there are no recommended guidelines for the measurement of and planning for the UHI. And these are the strategies. There are mainly 6 strategies. First is increased surface albedo, which is installation of cool roofs and green roofs, and then increasing the ground albedo by inclusion of cool paving technologies, etc. And then we are having increasing biomass by preserving the existing tree and planting more trees, such as to increase the tree inventory. Then we have another strategy is to reduce the exposure and vulnerability, such as installation of air conditioners and passive techniques, and a preventative healthcare system can be developed, and the health alert system can be developed. And then we are having the reduction in anthropogenic heat generation, such as urban planning, such techniques such as TOD and promotion of motorized traffic. Then 5th is increasing the thermal performance of the built form, such as widespread use of energy codes, and regular design and materials, climate sensitive urban design and planning. Then we are having laws, policies, and guidelines, which includes corporation standard assessment and planning techniques in guidelines, encouragement of clean energy systems, UHI adaptation measures. And coming to the proposal, first is cool roofing, which is classified to green roofs and white coated roofs, and these are some of the some of the main roofing technologies such as coating, liquid coated roofs, metal roofs, green roof systems, and use of clay and concrete tiles, which is white. And then the cool roofing plan is that the existing buildings, the concrete roofs can be retrofitted using liquid applied coatings, and metal panel system can be used. And for buildings with deteriorating conditions, buildings liquid applied coatings are preferred, and this is the implementation strategy. First is economic incentive for cool roofing. Giving economic incentive for the end users can promote the use of cool roofing technologies. Then use of incorporation of cool roofing requirement in municipality codes can also increase it will also increase the incorporation of cool roofs. Then use of energy code provisions such as for the commercial buildings and industrial buildings. Then for increasing public awareness, then for implementation of cool roofs in public buildings such as hospitals and schools. Then for the suggestions, these are some of the suggestions for the critical areas. First, for Matanjali area, which where retrofitting method is the best suited area, which is basically because the buildings are old. Then for second, for developing areas such as Trikakara, which is towards the east, where incorporation of cool roofing in the municipal code are just this region. And for three, which is industrial areas such as Illur, where mainly the roofing material is asbestos, where re-roofing can be done, or it can be painted white. Then the next proposal is cool pavement technologies, where about 7% of the KCR land use is in transportation, and the major of which is the roads. So these are some of the cool pavement technologies which can be adopted, such includes concrete cool pavements, white topping, which is on figure, and asphalt use of lower cool asphalt white aggregate, and use of porous paving materials, etc. And this is the implemented strategy includes the inclusion of cool pavement technology in public works through ordinances. Then cool pavement incentives can be given, and property tax and safeguard provisions can be used for private owners. Then the realization of tax and increased public participation, and then utility fee adjustment and building coverage provisions, the use of reflective materials for the paving maintenance. And coming to the increased biomass, the green cover has decreased from 49% to 37% from 2000 to 2019. So these are some of the least vegetated areas in KCR region, where the implementation of the biomass should be increased. Then implementation strategy include tree planting strategies such as tree planting tree planting programs can be organized by municipalities. Then the residential property, which is the largest segment, which considers 60% of the area, by simply adding 1 or 2 trees can increase the tree inventory. Then public property such as parks and open spaces shall be used for planting trees, and the commercial buildings can plant trees in the parking lots and around the buildings. The tree conservation strategy includes tree ordinances, and a master plan for a tree can be prepared. Coming to entrepreneurial heat generation, the urban planning techniques such as TOD and commercial traffic shall be promoted. And in the map, the upcoming metro stations are marked, and where the TOD can be best implemented. And the vehicle anti-idling use bylaws can be used to reduce the anthropic heat generations, and the major junctions are marked in the map, where it can be implemented. So to increase the thermal performance of build form, widespread use of energy code prevention shall be used. And the ECSBC can be enacted in the state, and the green provisions to be incorporated in the shall be incorporated. And these are some of the proposal for the new developments, where the orientation of main road should be in north-south direction, which decreases the mean radiation temperature, which is observed in the modeling part. And the building shall be oriented in the east-west direction, which decreases the heat gain. And the building shall be shall be designed. The layout of the building can be shall be decided by the direction of the winds. These are some of the figures showing the illustrating that that point. And this is all about the proposals. Thank you.